Hey guys, welcome back for day number 2. If you made it back today, that's good news because that means you survived day 1 of online learning. That was a big learning step for all of us. And you guys did great. You did fantastic. That actually went much smoother than I thought it would. So, yeah, good job on that front. Today, we are going to pick up where we left off yesterday. Yesterday, of course, we reviewed patterns and what they are and how to write pattern rules. And then at the end of the lesson yesterday, we got a little bit into T-tables about organizing patterns into a chart rather than into drawings. So we're going to continue where we left off yesterday. Today, we're going to have a look at function machines. And 2 weeks ago, I showed a video in class, and I don't think any of you have forgotten that by now because the video was so entertaining. It was that video where they took chickens was the input, and then they put the chickens through the machine, and out came chicken nuggets. Yeah, that's right. I remember I scarred some of you with that. But that's okay because I think you all learned something from that video. And so today we're going to continue on with function machines. Before we get into the lesson here, I just want to cover two things. First of all, our learning goal for the day. I can determine the pattern rule to make predictions about subsequent elements. So that is the same learning goal as yesterday. We're just going to look at it in a little bit different light today. And the second thing that I wanted to do before we dive into the lesson is to introduce you to a new word. I don't even think we got to discussing what this word means when we were in school together. So let's just make sure that you know what consecutive means right now. The definition of consecutive is numbers that follow in order. So I've got a couple of examples down below. I always find that definitions can be hard to understand until you put an example to them, because sometimes it's really helpful just to learn through examples. And so right here on the page, I have 1, 2, 3, 4, 5, 6, 7. And those numbers are consecutive because they follow in order. 1, 2, 3, 4, 5, 6. Those are all consecutive numbers. But below that, I have another example of numbers that are not consecutive, or numbers that do not follow in order. 1, 3, 6, 9, 10, 14. They don't follow in order, therefore they are not consecutive. And if I were to ask you, can you tell me the next consecutive number starting at 15, I hope that you would be able to start counting from 15 and tell me the next consecutive numbers, which are 16, 17, 18, 19, and so on. So that is what it means to be consecutive. That'll come up later on in today's lesson. So now you know what that means. Okay, well, I've got two examples of input-output machines here. On the left, we have one here where we put in a number 2 and it spits out a number 4. And in this one, you'll notice that the number gets bigger. But in this one over here, we put in a 5 and the machine spits out a 2. So this one's actually making the number smaller. So we're just going to talk a little bit about these two examples. Now, function machines use one of the 4 operations that we've learned about so far in school, either addition, subtraction, multiplication, or division. And 2 of these operations we can use to make numbers bigger, and 2 of these operations we can use to make the numbers smaller. So let me just go ahead and arrange these properly for you. Yeah, if we have a function machine that is making numbers bigger, we are most likely working with a machine that's adding or multiplying. And if we have a machine that is making our numbers smaller, it's probably subtracting or dividing. That'll be a helpful little hint to remember as we do a few of these examples. So the first example we're going to do together today is an input machine where it takes the number 1 and it spits out a 4. Or it takes the number 2 and spits out the number 5. So given what we just learned, it's making the number bigger, which means we're most likely adding or multiplying with this machine. So let's try. The obvious for me is if we take 1, we could add 3 to that to get 4. But the thing with this function machine is that whatever it does to one input, it's going to do to all of them. So let's test another one here. Let's go 2. Let's add 3 to that. Yep, 5. 3, we'll add 3 to that. Yeah, 6. Okay, so I think we just figured out our rule for our machine here. Let me pencil this in so you know what to write on your assignment. The rule for this machine is add 3. Just like that. Okay, now I'm going to bring you back to that word we talked about at the start of today's lesson. These numbers are consecutive, our input numbers. It goes 1, 2, 3, 4. And it also turns out that our output numbers are consecutive as well, 4, 5, 6, and 7. But the thing is, we don't always have to have consecutive numbers in an input and output machine. So for example, if I go to my next example here, here's my new input-output table, and you can see that I'm no longer working with consecutive numbers. I'm now skip counting 2, 4, 6, 8. But you know what? This machine's going to work the same regardless. All we have to do is look at the input and the output values, and we recognize that the number starts big and the machine is making it smaller. So we know we're either going to be using subtraction or division. Let's start with subtraction just because probably for all of us, that's an easier operation to start with. And if we put in a 2 into the machine and it spits out a 1, logically, I'm just thinking, yeah, that's probably taking 1 away. So let's test it out on a few of our other values here. 4, if we put that through the machine and it takes away 1, yep, we get a 3. 6, take away 1 is 5. Okay, so I think we've found our rule again. And so the rule would look like this, minus 1. Just like that. Okay, so let's move on to my third example. My third example, again, I'm not using consecutive numbers in my input values here. These ones now skip count by 5s, 0, 5, 10, 15. And, whoa. Now, if we just look at the first one here, that's not incredibly useful. Input 0, output 0, that could be like add 0, could be subtract 0, could be multiply by 1, could be divide by itself. So that one is not really helpful for looking at. But if we go to the second value on the table here, 5 is what we put in and 10 is what we get out. To me, that either means we are adding 5 or multiplying by 2. So let's test out another one here. 10 plus 5 would be 15. Nope, that's not it. So this one is probably going to be a multiplication problem. If we multiply by 2, 10 times 2 is 20. 15 times 2 is 30. Yep, that's the rule for this machine. And so the rule is multiply by 2. And let's do one more example here. Last example, we put in 10 and we get out 5. So if we try our go-to subtraction here, 10 minus 5 is 5. Yep, that works. But if we go 8 minus 5, that's 3, not 4. So this isn't a subtraction problem. This is a division problem. And what do we have to divide 10 by to get 5? 2. That's right. So 10 divided by 2 is 5. 8 divided by 2 is 4. And so on we go. So that would be the last rule here. Divide by 2 is our rule. All right, guys, we got one more slide to do here. Thanks for hanging in there with me. The last type of problem you might see with input and output tables is that they give you the rule, and then they ask you to use that rule to transform an input value to its output value. So let's use this rule. If we put in a 0 and multiply that by 3, that would give us 0. If we put in a 2 and multiply that by 3, that would give us a 6. Now, again, you'll notice that I'm not using consecutive numbers for my input values here. I'm skipping around 0, 2, 5. That means that we aren't going to be able to use patterns to predict the next one here. So let's just go input of 5. 5 times 3 is 15. And now the last one here is a little tricky because they give us the output value, but they don't give us the input value. But we know that whatever number we put into here, we're going to multiply it by 3. That's going to give us 27. This is where having your multiplication facts mastered is going to be really advantageous to you. Some of you have this memorized, and you'll know that 3 times 9 gives you 27. And so that's our last input value there. All right, so that's the lesson for today, guys. We have revisited how to use rules on input and output machines, and going both ways. We can look at a table and figure out the rule, and then in this last example, I gave you the rule, and you could use that to figure out what values go back into the table. So that's the lesson for today. Thanks for watching. We will see you tomorrow.